Now it's time to look into the variance and covariance, because we have seen expectation for we have calculated expectation for discrete random variable as well as continuous random variable. Now it's time to get into the variance and covariance. So in probability theory, variance and covariance are measures of the spread and correlation of a random variable with respect to its expected value or mean. So variance measures how far a random variable deviates from its expected value. Variance measures how far how far a random variable deviates from its expected value, while covariance measures how two random variables vary together. That's it. Variance of a scalar random variable tells us about its spread around its mean value E of x, that is equals to mu. Variance measures how far a random variable deviates from its expected value, while covariance measures how two random variables vary together. So first let's see variance. So this is how we calculate the variance. So variance of x, a random variable x, is equals to E, your expectation of x is your random variable, minus mu is obviously your expectation. So here you see that expectation of capital X, expectation of random variable, is denoted as a mu. So x minus mu whole square, E of x minus mu whole square. So then this formula can be converted into E of x square minus mu square, and this is how you calculate the variance of x. Okay. So in this case, I think it's better to use a programming language to calculate the variance of this random variable. It would be much easier. So variance of x is equals to E of x square, estimation of square of random variable, minus mu square, that is expectation square. Okay. So standard deviation is simply the square root of this variance. We know that. What standard deviation? If you know the variance, calculating the standard deviation is pretty simple, because standard deviation is simply square root of variance of x. So now covariance for two scalar random variables, capital X and capital Y, the covariance is defined by how the two random variables x and y vary together, and this is the formula to calculate that covariance of x comma y is equals to E of expectation of x minus E of x multiplied by y minus E of y. So this can be converted into the expectation of xy minus expectation of x times expectation of y. That's how we calculate the covariance. So covariance is equals to expectation of the product of xy and the product of expectation of x and y. E of xy minus E of x multiplied by E of y. So this is called the covariance. So we have seen variance, we have seen a standard deviation, which is the square root of the variance. Then we also have seen covariance of x comma y, two scalar random variables. Now, of course, that's a scalar random variable because it's a discrete. Now let's get into the continuous random variables. So for two vector random variables, we call them vector random variables x and y. So assume column vector. Okay, the covariance matrix is defined like this. Covariance of x comma y is equals to expectation of x minus E of x, y y transpose minus E of y transpose, then the covariance would be E of x multiplied by y transpose. That's one. You have to subtract E of x multiplied by E of y transpose. Only the difference between the scalar random variable and then vector random variable is a transpose, because here this is vector and that is scalar. So covariance of components of a vector random variable x. So if you want to measure the covariance of components of vector, maybe first component or second component of vector, then you can directly use covariance of x is equals to covariance of x comma x. Note the definitions apply to functions of random variable too. So this whatever definitions we have used for the variance, covariance, standard deviation, and covariance for scalars, covariance for vector. So this is directly we have used it for the random variables. Of course, this can be applicable to the functions of random variable like this f of x. Variance of sum of independent random variables, it's variance of x plus y is equals to variance of x plus variance of y. Now it's time to jump into one example. If not one, I will give two examples. What's there? So let me write it down. Variance, then square root of variance is standard deviation, then covariance. So example, suppose we have again a binary classification. Binary classification problem where x is random variable representing the probability of an image containing a cat and y is a random variable representing the probability of an image containing a dog. So we can so from this we can compute the variance of x as follows. So variance of x is equal to estimation of x minus mu power 2. So where E of x is so mu is nothing but E of x, estimation of the random variable x. So where E of x is the expected value of capital X, and E of x minus mu square is the expected value of the squared deviation of x from its expected value. So this gives us a measure of how much the probability of an image containing a cat varies from its average value. So now if you want a standard deviation, so it's a square root of variance of x. That's it. So now if you want to calculate covariance for the same example, so covariance for the same example x comma capital Y, because we have two random variables, it's E of x. Let me check the formula. That's okay sometimes. Yeah, E of x y minus E of x times y. That's what. Or another way also, you can put it in another way. So E of x minus E of x multiplied by multiplied by E of y minus E of y. So you can convert this into E of xy minus E of x multiplied by E of y. So where E of x and E of y are the expected values of x and y respectively. So this gives us a measure of how the probabilities of an image containing a cat and a dog vary together. So this gives us a measure of how the probabilities of probabilities of an image containing a cat and a dog vary together. So this is one example where we have calculated the variance, standard deviation, and then covariance. Let's take another example. So example 2 this time. Example 2. So suppose we have a language model. So language model that generates sentences. So x is a random variable representing the number of words in a generated sentence, and y is a random variable representing the sentiment score of the generated sentence. Sentiment score of the generated sentence. So we can compute the variance of x as follows. Now we can compute the variance of x as follows. So this time of course we can use a similar formula. So variance of x is equal to E of x minus either you can write it as E of x square, or in spite of E of x you can put the mu. So here where E of x is the expected value of a random variable x, and E of x minus E of x square is the expected value of the squared deviation of x from its expected value. So what does it do? So this gives us a measure of how much the number of words in a generated sentence varies from its average value. So we can also compute of course from this we can also compute st. So st is equal to square root of variance of x. Next we can also compute the covariance. We can also compute the covariance between x, random variable x, and random variable y, which represents number of words in a generated sentence and sentiment score of the generated sentence respectively. So now the covariance of x comma y is equal to E of x minus E of x minus E of x, and same thing you put it for e of y minus e of y. So this can be converted into e of xy minus e of x multiplied by e of y. That's it. So with this we can calculate the covariance. So here e of x and e of y are the expected values of capital X and capital Y respectively. This gives us, let me write down, this gives us a measure of how the number of words in a generated sentence and its sentiment score vary together. So with this, that variance and covariance are important measures in probability theory and statistics, as they provide information about the spread and correlation of random variables. They are often used in machine learning to assess the performance of models and to evaluate the relationships between different variables.